Yesterday, we looked at how moose and wolves, both examples of predator and prey, interact in an environment. Today, we're going to think about what that data shows us and how we can make predictions about predators and prey based off what we saw about moose and wolf populations. So we have 4 questions to start in this table on lesson 2, page 8. So the questions are: what happens to the moose when the wolf population rises? So go ahead and look at your table from yesterday. What happens to moose when the wolf population declines? So go ahead and look at your table from yesterday. What happens to the wolves when the moose population rises, and what happens to the wolves when the moose populations decline? More importantly, we're going to look here, general predictions about predators and prey. Think about what this tells us, right? If we see that moose populations fall when a wolf population rises, what does this tell us about predators and prey? And what happens when other things happen within that relationship, right? Think about the data we looked at yesterday. And then finally, 9 and 10, think about cause and effect relationships that underlie fluctuation in predator and prey populations. Think about if there's too much prey, what happens to that predator population? If there's too little prey, what happens to that predator population? Okay, and what specific data from the classroom rounds of predation, from that data we picked up yesterday, can serve as evidence? So at that, you'll look at your table from yesterday in lesson 2, page 7, and tell me what specific data from classroom rounds of predation can serve as evidence to support your conclusions. Okay. So now we're going to look at 3 case studies. Okay, today and tomorrow we're going to look at 3 case studies. Actually, excuse me, 4 case studies. Right, where we'll read the following cause and effect scenarios and answer the questions in our notebook on lesson 2, page 9. Our goal today is probably to finish up from 8 to 15. Right, questions 8 to 15. So we're going to look at wolves in Yellowstone National Park. Wolves were absent from the park for decades, meaning that there weren't wolves in this park for a long time. And elk populations grew, causing overgrazing. So elk overate the grasslands. The scientists decided to address this problem by reintroducing wolves, right? Our questions on 11 and 12 are: what changes do you expect to see in the elk and wolf populations? And finally, what specifically causes the changes you predict to occur in the ecosystem? So think about how a predator and prey interact the first time they meet. If this elk have not seen wolves for decades, are they going to identify them as predators at first? If they don't see them as predators as first, what are the wolves going to be able to do to this elk population? And finally, what do you think is going to happen if too many elks are killed in this ecosystem? Okay. Next, we're going to look at jaguars in Central America on lesson 2, page 9. Jaguars are the top predators in the rainforests of Central and South America. Their numbers are declining, but not due to a predator and prey cycle. Their change is due to habitat loss and hunting, meaning that where they live is starting to disappear in the rainforest. The lumber industry has cut down a lot of trees, and hunting, humans have hunted jaguars for a long time because of their pelts. So because of the jaguars disappearing, what do you think is going to happen to the coati populations, which kind of look like raccoons, as jaguars disappear, right? What would be the cause of this change? So with the jaguars disappearing, what would be the cause of the coati populations changing? And finally, overall, though, has an increase in the coati population, could it affect the population of jaguars? As more and more prey show up, what could possibly happen to the populations of jaguars?